I'm going to talk a little bit about first the mammoth excavation that was from 2002 to 2014. And then I'll talk a little bit about mastodons and mammoths to give you a little insight into their behavior and understand prehistoric St. Louis, what it was like 30,000 years ago. And then I'll tell you a bit about the recent excavation that I've been leading at Principia College. So I'm a college professor at Principia College. I teach art history and sociology, as Kemi said, but I also teach anthropology, archaeology, and recently paleontology. So I really only came into paleontology 2 years ago. I've been quickly learning up on the skills, the knowledge of that period. But I've done a couple of excavations at Principia College before. I did one of the first settlement in the area, Eminence, which was destined in 1830 to be the new Chicago, but they decided to situate it down here. So that was an interesting dig. I did a dig on Native Americans, an Native American settlement site. And that was also very interesting, but it kind of prepped me for what was to come. So I'll explain a little bit about that in a minute. But let me first start off with this question. So why do we love mammoths and mastodons so much? And you see them in popular culture. People seem to have been fascinated by them for a long time. In fact, we've always been fascinated by them. Prehistoric cave paintings, as early as 13,000 years ago, featured mammoths and mastodons. So there's been this interest in them. And I've tried to grapple with this attention as well, because the dig actually attracted 200 visitors, television, radio, newspaper interest that was not at all something that I'd experienced before. And the conclusion I came to, perhaps you have different ideas, but that these mammoths and mastodons seem to have nuclear, loving, caring families. They roam the earth as the largest mammals in the last 25 million years. They're also fairly alien. They have these massive tusks, and they're really, I think they connect us with this pristine and ancient past, which was very different here than it is today. It was a tundra during the Ice Age, where very little grew. It was mainly grassland, very, very cold. It would get a little warmer in the summers, but because of the high pressure system here, there was very little snow or rain, and so nothing really grew. Now this leads me to something that our dig actually has contributed. The presence of a mastodon in this area, which is likely the first mastodon to have been found in the Midwest by about 10,000 years, according to the Illinois State Museum, means that it has rewritten geological history. The landscape must have been more wooded than has previously been thought. So not only has this been a learning curve for me, it's been quite a contribution to have made, and a responsibility for communicating and excavating this mastodon right. So let me just go through the first mammoth or megafauna dig at Principia College. It is kind of surprising that we found two megafauna at the college, on the college campus. In fact, not many holes have been dug by the facilities workers at Principia at 12 feet deep. I think there are 4 or 5, and of those 4 or 5, 2 have yielded a mastodon and a mammoth. So there must be a lot more under the ground that we just don't see. This was found in about 2001. They covered it. A facilities worker was digging this hole, and his backhoe hit a giant tooth. And they concluded it must be a mammoth tooth, so they sealed it up, and they started a dig in 2002. That dig lasted 12 years, and it was one of the most significant finds in North America at the time, not only because it was almost intact mammoth, which doesn't occur very often, usually they're scavenged, but it was also on a college campus, which enabled it to be studied very, very carefully over this long period of time. By the way, it was called Benny after the facilities worker who actually discovered it with his backhoe. It is actually on display in the Science Center. You can actually go and see it at Principia College. And the great thing was that because it's at a liberal arts college, it enabled majors from many different majors from different disciplines to participate in the dig who were not archaeologists and experience this excavation, but also apply their different skills from their different majors. So it was it was sort of an interdisciplinary experience for these students over many, many years, and there's very fond memories of it. So when Mike Towle, the guy on the right top corner here, discovered our mastodon and contacted me, I kind of felt a little bit wobbly because I felt this responsibility that had come to me as an archaeologist to do as good a job as Janice Treeworthy, who was the geologist who excavated Benny. So I contacted Brandon Richardson at the University of Illinois. He did a ground-penetrating radar survey of the site and found that not only a tusk, but many different bones existed around the tusk. So we felt it was worth setting up an archaeological field studies course at the college to study it. Now, I couldn't do it right away because I hadn't really set it up, and I made the mistake once of doing an archaeological field studies course during the spring semester, and that was not a good idea at all because half the classes were canceled. So we set it for fall 2023, covered it up, and we named him after Mike, who'd found it, so it's Mike the Mastodon. Mike is a very retiring guy who doesn't like public attention, so he was a little bit ambivalent about being having it called after him. But he's a great guy, and it's a tribute to him. He just retired last year. So a little bit about mastodons and mammoths. So they have no relation to dinosaurs. Sometimes they get confused. I think mastodons came first. They evolved around 22 million years ago. Dinosaurs died out about 65 million years ago. I wanted to say something. Yes, so after we found Mike the Mastodon, it was very odd for Benny the Mammoth to be found on the top of the bluffs. Now, a mastodon or a mammoth that is injured or diseased would usually go down to a water source, usually the river or a creek, to die. So for many years, it was unclear how Benny died. He was up on the top of the bluff, the very highest point. And they concluded that he must have fallen into a sinkhole. Now, the limestone cliffs are full of sinkholes, and possibly he stumbled into one of these and then was quickly covered up by dirt. And that's why he was intact rather than scavenged. Now, it was really odd when we actually discovered that Mike, the mastodon, was also on the top of a bluff. I mean, two megafauna in a short distance from each other is enough of a coincidence, but two on the top of a bluff is really odd. So one of the main questions that we asked of this mastodon was, how did he die? So I hope that in this lecture I'll be able to answer that a little bit better than we were able to when we found him. All right, so mastodons and mammoths, as I said, evolved a long time ago. Mastodons about 22 million years ago. The mammoths evolved around 4 to 5 million years ago, so much more recently. Mammoths were closer cousins to African and Asian elephants, which actually have developed earlier than mammoths. But more is known about the mammoths because they're large. Their bones do not disintegrate. So if you find a mammoth, you really know you found a mammoth. They also were often frozen in the Siberian tundra. So in north of Russia, there are a lot of mammoths that have been found frozen, a bit like this, this baby mammoth that was found by a Siberian reindeer herder in 2007, Loyuba, the baby mammoth, and it's practically intact. In fact, has remains of her lost meal. From these frozen mammoths, we know a lot more about their physiology, about what they were like, with their habits, etc., than we do of mastodons. Mastodons eat more leafy, twiggy material than mammoths. So they had to be further south where trees lived. So they didn't tend to get frozen, and we haven't found their remains. So there's a lot less known about mastodons. Just a few distinguishing features about mastodons and mammoths. Let's see. So it was difficult for us to determine what this was to begin with. The tusks of mastodons tend to be straighter than mammoths. Mammoths' tusks tend to be a little bit curlier. But the biggest distinguishing feature between them are their teeth. So mammoths tended to eat grass, and therefore their teeth were fairly flat for grinding the grass. And mastodon teeth tend to be a lot scarier. They're these fangs. And they were used for eating bark off the trees. Then they would push the trees over, and they would eat the leafy matter, twigs, branches, and they need to really crunch those things up. So their teeth are a lot more spiky. So a few more facts about mastodons and mammoths. So their feet are fairly leathery and cracked, so they could walk on ice. They had grip. Mastodons tended to have stockier, more muscly legs, so it's likely that they were able to run faster than mammoths. Interestingly, there are fewer mastodons that were hunted by Native Americans while they both coexisted, which indicates that perhaps they were a little bit more dangerous, especially with those pointy tusks. So they may have avoided the mastodons and just hunted the mammoths. They were completely vegetarian, both of them. We know this from their teeth. But mastodons and mammoths moved into North America about the same time, about 100,000 years ago. when the Bering Strait, the landmass between Russia and Alaska, was actually exposed, and they could just walk across. In fact, over perhaps 30,000 years, native people have followed these herds into North America from Siberia. There are a few examples of native people living here around 30,000 years ago. That is becoming more established, but it's very far and few between. The largest wave, I think, of people, Native Americans, into North America was around 13,000 years ago, with a culture called the Clovis culture. And it may have been their technology that enabled them to basically hunt mastodons and mammoths to extinction at around 10,000 BC. So we did a radiocarbon date that I confirmed with another radiocarbon date of our mastodon. Benny was around 17,500 years ago, so outside the window of human occupation in this area. And Mike the mastodon is 27,500 years old, so way outside the window of that large wave of human occupation. All right, so I want to just tell you how rare it is for a mammoth or a mastodon to actually get killed. There was a danger if you were a baby mammoth. Dire wolves could pick off the weaker and the smaller mammoths. But as a full-grown adult mastodon and mammoths, you were formidable. You were at the top of the food chain. The tusks at one swipe could kill a mountain lion or a saber-toothed lion or a dire wolf. The trunk could break the back of an animal, or they could just use those stompy feet. There are plenty of weight on those animals that they could use to their advantage. The most dangerous, or the greatest danger that they actually had was each other. So in the springtime, males would fight each other over females, and there are several examples of mastodons or mammoths that have been killed by each other. In fact, there are cave paintings that have been found of mammoths fighting each other as well. So from these cave paintings, incidentally, we know a little bit about their behavior. We know about that they were generally brown or orange-brown colored. Their fur was orange-brown colored. We also know that there was this affection that I mentioned previously to mammoths and mastodons, probably because they fed them very well and fed them for 1,000 years. A little bit about the environment. So the environment, I don't know if you know much about the last ice age. Interestingly, 30,000 years ago was the peak of the ice age, and or the last ice age. The light blue is an earlier ice age, and the extent of this glacier that extended all the way down to here was quite interesting for me, just learning about this, because it helps to understand the geology of this area. So if you can understand, these glaciers are actually moving. They're like rivers. They move about a foot, sometimes a day. So when they move, this huge wall of ice that was up to, I think, several miles thick in the north, less so towards the south. But if you can imagine that huge body of moving ice, it basically scraped everything flat. It filled in the ravines, it scraped away the hills and the mountains. So everything that you can see in the dark blue is basically a plateau. Many hundreds of miles of where the elevation is just 8 inches high. I mean, it's you've seen it, you've driven across it. That helps to understand that geology. Now, the reason we are so hilly around here is that we are at the southernmost extent of it. And all that stuff that was scraped off the land was deposited here. And so explains why we have bluffs along the Mississippi. Now, the other interesting thing is that the rivers were carved by the melting of these glaciers. So in the summer, it could be very, very cold. It could be the peak of the ice age, but there would be some melting of the glacier that would cause increasingly large torrents of water that form the Mississippi. And you can see that the contour of the Mississippi pretty much follows the glacier, as does the Missouri River to the left. South of the Missouri River, south of the glacier there is basically the line of the Missouri River. And these rivers were enormous, torrents of 100 feet deep, 11 miles wide, that carved the bluffs that run along the Great River Road. So that was, for me, fascinating to understand how this geology formed. And when these torrents of water melted, they made the sides of the banks of the river green and verdant. So the mammoths, mastodons, were attracted to this very light, verdant material, right, along the river. However, what happened in the winter was a little bit more horrific. So we can understand this from the stuff that we dug Mike out of. So in the summer, you would have seen these huge rivers that would have carved the sides of the bluffs. The mammoths and mastodons were attracted to this region. But in the winter, the glaciers would refreeze. The water would dry up, and what would be left is all this glacial silt, this tiny dust that would have been whipped into these horrific dust storms, these tornadoes of dust that deposited over 50 feet of material on the top of the bluffs. So we were digging 12 feet deep. There was another 40 feet deep of this dust that we were digging through. It's wonderful material. It's for digging is great, except unless it dries out too much and you step on it and then it compacts into almost cement. But I've never dug anything that actually makes your hands feel moisturized after. It's usually the opposite. So this is one suggestion for how Benny died, that he was covered or choked to death with these dust storms, and then was covered by it so that he wasn't scavenged. And it may be the case for Mike as well. So in fall 2023, I set up an archaeological field studies course. I had about 10 students. We started digging. The facilities kindly set up this structure over it that prevented the rain and the sun from deteriorating the bones. And we also set up a porta-cabin, which was the archaeology site laboratory and the site office and a classroom. So I was able to teach the students every day archaeological techniques, site formation processes, about mastodons and mammoths, skills, conservation techniques, etc. And then we were able to go and actually practice those skills immediately on site, which was, I think, a perfect experiential opportunity. And I created a rota for the students. Here they are. So I would pick them up on campus. It's about a mile away in a van, and we would go up to the site. I would give them a talk for about 20, 30 minutes, and then we would go down to excavate for a further 2.5 hours. So we did that twice a week. And I tried to use as much technology as possible because we had a limited amount of time, and the recording, the writing, etc., needed to be quickly done so that we could get down to the excavating. We had a pulse laser which shoots a laser at all the artifacts we find, all the bones, and logs it within a couple of millimeters of with the GPS coordinates. And then I created an iPad app to record the data as we were digging. So I split the students up into a couple of people to do each of these tasks every class, including sifting and excavating, and they rotated, so they got to practice all these skills. And I tried to get different tasks allocated to different majors. So the engineers helped me with the structure, sort of mitigating the water, preventing water damage. We had artists who were able to draw the finds. We had biologists who helped me analyze the bones, chemists who ran the archaeology conservation lab. We had a mass comm student who set up the time lapse and a website. We had computer scientists help with the website, and then we had some journalists actually help write a paper for a conference. So I tried to allocate jobs for to their skills. So I might as well show you the dig in entirety. We did this time lapse that can show you how we did the excavation, and I'll try and talk you through what we were doing here. But let me get it started. All right, so this is us starting at the top. We would dig about 30 centimeters down at a time and then record what we found. Each time using the total station to log the coordinates of each find. And we found a bunch of skull fragments. So it was obviously scavenged by probably dire wolves. The tusk was too heavy, it didn't have any meat on it, so it wasn't dragged very far. But we started finding a lot of charcoal around the tusk, which was very odd. And you can see that everybody's using trowels to begin with. Trowels are a sort of a way of being careful about what you're excavating. And we troweled down the entire site. It was about a 3 by 3 meter site, very carefully until we reached the point where there were no more bones. And then we started using shovels. I think you can start seeing the shovels here. Each step, they're sifting the soil so that we don't miss any little bones or any possible artifacts. We did find a couple of what looked like points, stone flint points in a couple of the bones, which made me excited. Perhaps there was human butchery at this site. But the date kind of precluded that. But who knows? So one of the interesting things that we found here was at the very tip of the tusk, you can see that it's blackened. It was completely charred. Let me see. There we go. I'll talk about that in a minute. What we did was, if a bone was too big, we would plaster cast it and then bring it to the Portakabin, where the students would carefully take the earth out. And what you saw there was a very disintegrated tusk, largely because of the bulldozer that went over it, but also because it was so old. So it's very acidic soil, and it's difficult to preserve bone within acidic soil. So what we had to do is we applied a mixture of Butvar, which is a resin, to ethanol, and that soaks into the bones and stabilizes it. It's almost like a nail varnish. It's you can't see it, but it actually manages to consolidate the bones. So we did that every time we would excavate or uncover the bones. So here's a 3D scan of the tusk. Fortunately, it was a lot more preserved underneath, so when we took it out, and I'll show you a picture of that, half of the tusk was very stable. But at the end, you can see the charred tip. Now that led us to a kind of interesting conclusion, including the charcoal that surrounded the tusk. We kind of formulated a hypothesis that perhaps being at the very top of the bluff, Mike was struck by lightning. Now, this would also explain the friable state of this tusk. I mean, if anything's hit by 300 million volts, it's not going to do very well. There was another problem, which was the very tip was broken off. So we were trying to figure out what that could mean as well. And African elephants often stay with the dead of their dead companions for several days. Some actually even bury their dead and fight off scavengers. And we thought, well, perhaps this happened here. Maybe one of its companions accidentally stepped on its tusk and broke it off. That's the only conclusion we could understand, because tusks are fairly strong. Unless it was struck by lightning and fell over and broke at the tip of its tusk off, maybe that was another conclusion we came to. So the second season, we started to dig the skull. And the skull, this was actually uncovered right at Halloween, which was very appropriate. The students were pretty freaked out by these huge fangs that emerged from the soil. It was also 3 days before the students were to present at a major national conference. So we had to quickly adjust all our conclusions to match the mastodon. We had finally figured out that it was a mastodon from these teeth. And here they are. So the very last day of the dig was a bit of a rush, but we actually had to hoist it out of the ground. We couldn't just leave it there. And media services actually sent a publicity announcement to all the newspapers, TV and radio, that we were going to lift it out of the ground. And it became a bit of a media circus. I think there were about 60 people there watching us, plus TV crews and radio crews. And I was terrified because, I mean, you breathe on some of this bone and it just disintegrates. So we actually got it out of the ground without one single accident or anything crumbling. I was very, very proud of the students. So this is the end of the tusk. We had to cut it into sections because it was too friable, but you can see the other side was fairly stable. And these teeth are remarkable. So this is the jaw, and the enamel, I mean, it's better than my teeth on these teeth. They're almost 30,000 years old. They have a little bit of some cavities there that can't look too comfortable for Mike. But yeah, he kept good care of his teeth in a large part. And actually, being able to say to your dentist that you actually worked with dental tools, nonetheless, on mastodon teeth, it's quite something. All right, so what we know about Mike the mastodon, he's a male, about 50 years old. We can tell this because females were a lot less than the 20 centimeters thick tusks. It was 8 feet long also, which indicates that he was fairly old when he died, and probably about 50. So what happened? How did he die? So around 27,000 years ago, Mike was chewing through some nice fresh greenery along the sides of the river, along the bluff, oblivious to this enormous storm that was brewing in the west, that was heading towards him. And it was too late by the time that he realized, when his hair started going on end, that he was imminently going to be struck by 300 million volts. Probably fell a few feet, maybe broke his tusk, but was likely scavenged by dire wolves who made quite a meal of him, left his jaw and tusk, but probably the first mastodon barbecue that they'd ever tasted. So, thank you for coming to watch. This is an exciting dig to have been on. As I said, maybe one of the first mastodons in the area, maybe rewriting geological history because mastodons ate trees, basically. And we didn't know that there were any trees for another 10,000 years here. So it's a work in progress. I'm trying to publish the results of it in a journal soon. But I'm very grateful to these students who helped me along the way, using all the skills that they had from their majors. And thank you for coming.